Welcome to the Diabetes Bio Podcast, a podcast for the Diabetes Journal, the flagship research publication of the American Diabetes Association. Each month, we will interview one or more authors from the feature articles, the papers of the month, or other articles published in that month's print issue of the Diabetes Journal. We also have a Sweet Talk segment of the podcast, which is more of an open format discussion of additional articles, conferences, or major events in the field that we'd like to highlight. My name is Darleen Sandoval, and I'm joined by my podcast co-hosts, Dr. Kirk Habiger and Dr. Kevin Williams. We're actually recording this just days after the completion of ADA Sci sessions. How's everybody doing? How's the recovery from the Orlando heat going?
Unfortunately, I think it followed us up here.
Yeah, it was pretty hot. It was hot outside, but the science was hot inside as well.
Yeah, that's right.
It's a good time. You know, we had that live recording of the podcast.
Yeah.
With all of the hosts, Neil Skolnick, Alice Chang, and Michael Rickles. And that was a really wild experience to be in front of an audience. What did y'all think?
It was definitely different. I tried to just imagine that I was in my office just looking at you guys via Zoom. It's a little easier than having to look out in the audience, but it was pretty fun.
Yeah, I enjoyed it. It was good to hear the perspective of our clinician colleagues and what they took away from the scientific sessions, you know, because we always go for the very hardcore basic stuff. And that was pretty cool to all sit down together.
Yeah, it's something that we don't get to do very often, to really have that interaction with the clinicians, right? To have that back and forth about science from the two different perspectives. So I think it was fun. So listeners, stay tuned. That should be posted at some point by the ADA staff.
And it was nice for them to let the babies come in. We're the babies of the podcast team.
That's right.
Only been around for like 6 months. And then they've been around for multiple years. Alice,
Exactly.
Mike, and Neil, and you guys, y'all did a phenomenal job. It was really a nice experience, and really proud to be a part of that journey of trying to build this podcast team for the Diabetes Journal. So exciting to see this move forward.
Yeah, right back at you. This has been really fun. All right. Well, we should actually get to work and tell the listeners what we have in store for today's episode. Kirk, why don't you get us started?
Thanks, Dar. This month, we'll talk to Dr. Jordan Wright, who's an assistant professor of medicine at Vanderbilt University, about his manuscript titled Exocrine Pancreas in Type 1 and Type 2 Diabetes, Different Patterns of Fibrosis, Metaplasia, Angiopathy, and Adiposity. We will also hear from Dr. Lisa Smeehuijzen, a PhD candidate in human nutrition and health at Wageningen University, her work titled Immunometabolic Signatures of Circulating Monocytes in Humans with Obesity and Insulin Resistance.
Awesome. And Kevin, we have a very special Sweet Talk. I feel like it's a very special Sweet Talk segment.
It's timely.
Why don't you tell us about it?
It definitely is. Today we have the pleasure of interviewing the latest recipient of the Banting Medal for Scientific Achievement, Dr. Rury Holman. His contributions to diabetes research are really nothing short of extraordinary, and I'm sure you're all going to find his insights fascinating. And also, this is the rare instance where we, as co-hosts, are all together for an interview. So that's fun too. It was really nice to see him give his talk at the Sci Sessions in Orlando just over this last weekend and receive the Banting Medal. That was really fantastic. Really loved the science, and his wit was something I wasn't expecting. It was funny to see all of the references that he had in his presentation. Definitely tune in for the Sweet Talk segment coming up.
All right, let's get started.
Today, we're going to discuss the paper of the month from July 2024 issue of Diabetes, which is titled Exocrine Pancreas in Type 1 and Type 2 Diabetes, Different Patterns of Fibrosis, Metaplasia, Angiopathy, and Adiposity. Today, we're joined by the lead author, Dr. Jordan Wright, who is an assistant professor of medicine at Vanderbilt University. Welcome, Dr. Wright. Congratulations on your paper, and thanks for being part of this month's podcast.
Thank you. Thank you for having me.
So Jordan, we do like to put our authors a little bit on edge with the first question. So this is a question we did not provide you. It's a little bit of an icebreaker question. So I'm going to ask you to tell us a fun fact about yourself that has nothing to do with science.
just this year, I'm celebrating my 20th wedding anniversary, and 2 days ago, got back from Cancun celebrating with my wife. So
Ooh,
getting back into thinking about science again.
that's very nice. And thanks for for joining us on a podcast so soon after a nice beach vacation.
Thank you.
Yeah, we'll try to keep this relaxed for you.
All right.
All right, Jordan. So as we get started, we'd like to give you the opportunity to highlight any other contributing authors or collaborators to this work, anything that you'd like to add at all.
Yeah. Foremost is Adele Escaros. He's a clinical pathologist that did a lot of the work analyzing the tissues that we studied. Al Powers and Marcela Brasova really laid the groundwork for obtaining the tissues and are excellent mentors. And then Rita Bettino at Pittsburgh, she's been instrumental in acquiring these tissues and processing them for years now and continues to do great work there. And then all of this is possible because of our collaborations with the Human Pancreas Analysis Program and NPOD to acquire more samples. So those have been the really key players in this project.
Wonderful. And you mentioned Al Powers as your mentor. Maybe this is the best time to talk about a summary of that research program and how it kind of led you to this project.
Yeah. So Al Powers, he's internationally known as a human biologist. I think for decades now, he's really pushed the idea that we really need to study the human pancreas to understand human diabetes. And he's helped to establish a lot of the groundwork for studying these tissues. Here at Vanderbilt, we've been fortunate to have him pushing that. We've also had Marcela Brasova, who runs the human islet phenotyping program as part of the integrated islet distribution program. They're both experts in studying and understanding the human pancreas and disease and have been really pushing that. And so the work they've done to establish this infrastructure really made the study that we did in these human tissues possible.
Very good.
So, Jordan, if I'm correct, you're a newly minted assistant professor. Is that correct?
That's right.
Awesome.
Congratulations.
Thank you.
So, before we get into the nuts and bolts of this study, why don't you tell us a little bit about the research program that you're hoping to build?
Yeah. Yeah. So I have a strong interest in building on what I learned from Dr. Powers and focusing on studying the human pancreas in diabetes. And so I've kind of got two branches of areas I'm focusing. One is in a more type 1 focus, one's a more type 2 focus. In the type 2 focus, we're working to improve models to study islet amyloid in the human pancreas. And the type 1, we're building on this project, looking more at the exocrine endocrine interactions in type 1 diabetes.
Very nice. So now let's get to this study. Compared to previously published work that has examined pancreatic acinar tissue, you had a unique selection of samples and some unique opportunities with this particular project. So can you tell us about that, about where you got the tissue samples and how you processed the tissue for this manuscript?
Yeah. And I mentioned this infrastructure that we've established over the past decade or so. So we work with local organ procurement organizations, NDRI, IAM, multiple organizations to acquire transplant grade organs. So these are deceased donors that their other organs are going for transplant, but their pancreas is not. And so we're able to acquire these high quality, well-preserved tissues. The tissues are sent to our collaborators either in Pittsburgh or Philadelphia for processing, where in addition to other processing that we can do for this project, they fix some of the tissue in formalin and embed in paraffin for staining, as we did in this study. And so it's really a collaboration between our group, multiple organizations, the HPAT program, and we also got some tissues from the NPOD organization out of Florida to build up our numbers.
Excellent.
It's a great example of team science and working across not just the institute, but institutes. So very cool.
Yeah.
I think another strength of this study was your correlations between those pancreatic histology findings, along with age, sex, BMI, and diabetes type, right? One of the things that I noticed was that you reported disease duration, but I didn't necessarily pick up on the correlation there. Was there any insight that you can provide us with the length of disease state and then how that directly affects the histological findings?
Yeah. So we certainly analyze how all the histologic findings correlate with disease duration. The disappointing part in that is that there weren't a lot of very strong correlations with disease duration. I think that's really
Got it.
still limited by our sample number.
Sure.
But there were some correlations. For example, the looking in specifically in type 2 diabetic donors, we did see more pannin, more pancreatic intraepithelial neoplasia, that pannin correlated with disease duration in type 2 diabetes. Yeah, other than that, we didn't see strong correlations with disease duration. But I do suspect with more numbers, we would probably see more correlation there.
Sure.
I'm guessing you were limited by actually getting a wide range of disease duration, right?
Right.
Especially probably for the type 1s.
Yeah, for type 1s, we don't have a lot of very early onset. We also don't have very long duration diabetes. So we were limited in our span on that. Definitely.
Yeah. But something hopefully you can get to in the future.
Yeah. We're definitely still collecting samples and working to build up that repositories.
Yeah. Given prior reports, maybe in particular in comparison to preclinical work, were you surprised by the lack of steatosis and inflammation in the exocrine tissue of the diabetic groups in particular?
Yeah. But particularly in type 2 diabetes, there have been multiple imaging MRI studies reported increased fat in the type 2 diabetic pancreas. So we were surprised to really not see that increase in pancreatic fat in diabetes. And that's part of why if you look at how we analyze it, we approached it in multiple ways, trying to confirm those results. And all the ways we analyze really confirm that there isn't an increase in adipocytes in the exocrine pancreas in type 2 diabetes. The caveat there is that we did not look at intracellular fat. So Roland Stein here at Vanderbilt, other people have looked at lipid droplets in the pancreas in diabetes. And so that's an area we are interested in looking at more to see if there's a difference there. But in number of adipocytes or area, there really wasn't an increase as we thought there might be.
Thank you.
So you highlight that in these samples, you saw profound fibrosis, but no classic inflammation, as we just noted, right?
Yeah.
Is there a possible scenario where the inflammation was rampant at some point in time and then has waned, and then based on when these samples are available, right, we don't see that? Or do you have any other insights you'd like to share?
Yeah, I think there's an important distinction here between the two, the type 1 and type 2 diabetes. So in reference to that question, in type 1 diabetes, I think it's very likely that there's an early wave of more intense inflammation that may be driving that. By the time we have the tissues, we don't really see it, that inflammation.
Sure.
And we just see the remnants as manifest maybe by fibrosis. In type 2 diabetes, I think that's probably less likely. I think probably that it's an ongoing chronic low-level inflammation that may be driving the fibrosis. And I think our results may provide a hint to that finding, because the distribution of the fibrosis between the two diseases was different, where in type 1 diabetes, we see a more profound inflammation in the duct and vessel area, where in type 2 diabetes, it was more parenchymal, diffuse throughout the exocrine tissue.
Interesting.
For someone who's maybe not as well versed in the anatomy or the gross anatomy of the pancreas, what does that mean at the physiological level, right? Can you help me with the difference between those fibrotic states and what that might actually mean to the patient?
Yeah, the short answer is I don't know.
And that's fair.
because we don't have functional studies to match with our histologic studies. So you can imagine the state in type 1 diabetes where you have fibrosis more around the ducts or vessels that could definitely influence function, movement of digestive enzymes out. But this is all speculation.
Sure. Thanks.
Are there any other key points or thoughts that you'd like to highlight from this work?
Yeah, I think the major point to the audience in general is that we always focus on islet biology as drivers of both type 1 and type 2 diabetes, and that's understandably so. But I think more and more there's evidence that this is a disease that affects the whole pancreas. For the clinicians, there's evidence that as much as 25% of people with diabetes also have clinically relevant enzyme deficiency. And so when we're seeing patients that may have upset stomach or other GI symptoms, remember that we need to be thinking about more than just the blood sugars in this case.
This is a bit of a reach, but do you think there is more of a back and forth between the exocrine and endocrine that both contributes to the disease as well as to the complications of the disease? I remember back when I was doing clinical research at Vanderbilt, we had a type 1 diabetic patient who got a very late onset type 1 diabetes diagnosis, and it was after he had a bout of pancreatitis.
Yeah, I think certainly, and there's certainly the exocrine pancreas related diabetes. Whether that should be called type 1 or not is debatable, but certainly there's an interaction between the two. We see it in cystic fibrosis related diabetes as well.
Yeah.
But we don't really understand really well the nature of that communication. That's something I hope we can do more. There are people that are working to better understand the vascular communication between the two compartments, and especially in the human pancreas, that's a hard thing to study because we can't model it as well as we can in rodents. But I think there's good work to be done there that will help clarify these questions.
So, where do you want to take this next in terms of some basic research questions that you'd like to address?
Yeah, I think there's mechanistic questions about what is driving these changes, and I think there's timing questions that we are working to understand. So, when in the course of diabetes onset do we see these changes? We continue to work with doing imaging studies in people at risk for type 1 diabetes to better understand when these changes may occur. And mechanistically, we're working to better understand by applying more advanced techniques. So this study is very basic techniques, using mostly H&E staining of the pancreas. We're looking to apply spatial transcriptomics and highly multiplexed imaging to really get as much information out of these donor tissues as possible.
Nice.
Well, Jordan, I just wanted to thank you for joining us today, for sharing your expertise, and for talking about your recent work on the morphology of the exocrine pancreas in type 1 and type 2 diabetics. I encourage our listeners to read the full article in the July issue of Diabetes.
Great. Thank you for having me.
Next, we're going to discuss one of the feature articles from the July 2024 issue of Diabetes, which is titled Immunometabolic Signatures of Circulating Monocytes in Humans with Obesity and Insulin Resistance. Today, we are joined by the lead author, Lisa Smeehuijzen, PhD candidate in Human Nutrition and Health at Wageningen University in the Netherlands. Welcome, Lisa. Congratulations on your paper, and thank you so much for being a part of this month's podcast.
Thank you. Thank you for the invitation.
So, Lisa, we like to start with a non-science question, just to kind of break the ice and get things going. Can you tell me maybe how your personal life intersects with your work, and help us get to know you a little better?
All right. Yes, of course. Well, in my personal life, I see a lot of people in my family struggling with obesity, and of course, I also see the impact of obesity on their daily lives and in their health. So in my research, I try to understand how the immune system plays a role in obesity and the complications of obesity. And I think, or at least I hope, that I can contribute with our research to understanding how the immune system is involved in these complications, but also how we can use it to prevent these complications in the future.
Wonderful. Thank you.
Thanks for sharing that. Before we get into the nuts and bolts of this particular paper, I want to give you the opportunity to highlight any contributing authors or collaborators on this work.
Yeah, thank you. Of course, I had a lot of help from my colleagues in the lab, from Frank and Jolene. They were of great help with all the experiments and the analysis in the lab. And Anouk, she played a very important role because she was in charge of the whole organization of the study and the recruitments of the participants. So without her setting up the study, we would be nowhere, basically. And then we got great help from Maddie, who helped us with the data pre-processing of the seahorse files, so the measurements to measure monocyte metabolism, because we faced a problem that it was never done in such a large cohort. So we had so many data and we didn't know how to work with this. So he helped us out with that. And of course, my supervisors, Rinke Stienstra and Lydia Offman, they supervised me during this project. Yeah.
So as you mentioned, this work was conducted under Dr. Stienstra and Offman's mentorship. So, from a more bigger picture perspective, can you give us kind of a summary of their research program and how it led to this particular research project?
Yeah, of course. So I think Insider's research is mainly focused on the innate immune system and how the metabolism of innate immune cells are involved in shaping their function. And he aims to focus on the contribution of the innate immune cells on complications of obesity. So, for instance, type 2 diabetes, but also complications of type 2 diabetes. Our study was mainly focused on, okay, how are these innate immune cells involved and the metabolism involved in the development of metabolic complications of obesity. And Lydia, her research is mainly focusing on precision nutrition. In the context of our study, we aim to understand what the inter-individual variation was in innate immune cells and particularly their metabolism. And yeah, basically with the idea or with the goal to understand this inter-individual variation to maybe in the future be able to design personalized strategies that target the innate immune cells.
Awesome. Kirk?
All right. So in the paper, you state that there's a strong association of obesity with impaired immune function. And the article, as I read it, aims to study the metabolism of monocytes, right, as a function of body weight. Can you go into a little bit more detail as to why monocyte metabolism informs us about immune function and then specifically the correlations with obesity?
Yeah. So previous studies already show that immune metabolism is important in shaping immune function. These results are mainly found in animal studies or in vitro studies. And we could show in our human cohort with almost 200 participants that we found strong associations between the metabolism and the function of immune cells. So I think it is important that there's an important hypothesis in the field that changes in the metabolism of immune cells precedes functional changes of immune cells. And we know that immune cell functionality changes upon obesity and upon metabolic complications of obesity. So these, if you could detect any changes in the metabolism, they may be early markers for changes in immune function or maybe even dysfunction. So therefore, it's important to study the metabolism of immune cells in the context of obesity. And in our study, we indeed observed an association between the metabolism of immune cells and the function. So it's cytokine secretion as a measure for immune function.
Right.
And we also found an association between monocytes metabolism and the level of insulin resistance. So not really body weight or obesity, but really the level of insulin resistance was associated with the metabolism.
Very cool.
And I think that's an important finding, that we didn't find this association with the BMI of the participants, but rather with the level of insulin resistance.
So let's go back and talk a little bit more about your subjects and the methods you employed to get the sampling and study these relationships between monocyte metabolism and insulin resistance. It seems like one of the strengths of this particular manuscript was that you had a large sample size. Is that correct?
Indeed, yeah. We almost included 200 participants.
Where did these subjects come from?
So they were recruited for another study that was conducted in our research facility. And we specifically recruited individuals with overweight or obesity, but without established metabolic complications or diseases such as type 2 diabetes or cardiometabolic diseases. So we aim to include a relatively healthy study population, so individuals who have overweight or obesity and who are at risk for the development of metabolic complications, but without established metabolic diseases.
One of the other things that I thought was really interesting about your paper, and I think you said you had help with this, so maybe you can't speak into too much detail, but this idea of the data pre-processing of the seahorse data sounded really intriguing. Can you talk a little bit more about that?
Yeah, so we measured the metabolism of the immune cell or the monocytes using a seahorse machine. And we did this with fresh samples. So every test day, directly after the collection of the blood samples, we isolated the monocytes and we measured their metabolism on the seahorse right away. And in the end, we ended up with so many data files, and there were not by then, there were no efficient methods to process this large amount of files. and also to standardize the cleaning of the data and the calculation of the variables, because the data is kinetic, so it's measured, the metabolism is measured over time, but we wanted to extract the maximum responses. So therefore we got great help from Mehdi, and he created the pipeline for us to automate these steps, which was really nice, because in the beginning I started to do it myself, but yeah, I wasn't not so efficient. And in the end, with the help of his pipeline, we could pre-process these data within a few minutes. So
That's amazing.
that was great. Yeah, that was a lot of help. Yeah.
Really cool.
You document some interesting differences in the metabolic and also cytokine responses to metabolites versus an immune cell activator drug, right? PAM3 cis, right?
Indeed, yeah.
I guess first, for those of us who maybe aren't immunologists, right? What is this drug? What does it mimic in terms of an immune challenge, right? And how do we interpret that?
Yeah, so PAM3 cis is a bacterial component. So it activates the TLR receptors and thereby basically mimic a pathogenic activation of the monocytes. But we mainly use this PAM3 cis because we knew from previous studies that it would provoke a maximal glycolytic and oxidative metabolic response. And we were mainly interested in these glycolytic and metabolic oxidative metabolic responses of the monocytes. Basically, what we did, we gave a lot of this PAM3 cis, like for a maximum activation of these immune cells to really get into this maximal metabolic responses of these immune cells, because we assume that the maximal metabolic capacity would be important for their function, which might then be important for metabolic complications of obesity.
Great. And then maybe just a highlight for us your results specifically on the metabolism of those monocytes.
We're not really sure what to expect because we don't really know what is a good metabolism or a bad or unhealthy immune metabolism, because it's not studied that often in humans yet. So we were really focusing on getting an idea of this variation and these metabolic responses. But we expected to find at least an association between the metabolic rates, so the maximal glycolytic or the oxidative metabolic rate of the immune cells, and maybe BMI or the level of insulin resistance. But we did not. But we also calculated the metabolic dependency of the monocytes, which is then the relative utilization of glycolysis to oxidative metabolism. And we found that this particular metabolic dependency of the monocytes was then associated with insulin resistance. And I think that is interesting because we don't know that much about the metabolic dependency of immune cells and how important it is for immune function. We know that the rate of metabolism is important for the level of cytokine secretion. We also could show this association in our study, but there's not that much known about the metabolic dependency and how important it is for immune function or its contribution to chronic inflammation and obesity, metabolic complications.
Yeah, I actually found that really fascinating that the insulin resistance was associated with a more oxidative dependency, right? Because I would assume that these individuals would be, at least at times, hyperglycemic, right? Mm-hmm. And so you'd think that those monocytes floating around would be exposed to lots of glucose and that they depend on the glucose. But you guys kind of found the opposite, right?
Yeah, indeed. Yeah.
Really fascinating. Okay. That's cool.
So to dig into this just a little bit more before we wrap up, so you found that insulin resistance was specifically negatively associated with CXCL11. So can you tell our listeners a little bit about what that is and why it's important, why that particular finding was of interest?
Of course. Well, CXCL11 is a chemokine that can be measured in the circulation, and it's involved in chemotaxis of various immune cells, including lymphocytes, but also monocytes. But at the same time, monocytes can be an important source of CXCL11 in the circulation. So that is, it can, both have an effect on the monocytes, but it can also be produced by the monocytes. We don't know how CXCL11 is involved in monocyte metabolism. And as far as I know, there are not that many papers out there that show a specific role for CXCL11 in obesity or type 2 diabetes. But we found that it was negatively associated with the level of insulin resistance. And it was associated with a metabolic dependency of monocytes towards this oxidative metabolism. So there may be a link between insulin resistance and monocyte metabolism that is somehow works through circulating CXCL11, and whether this is a bidirectional relationship or there's any causality involved, that's something that we couldn't prove because our study was not designed to conclude anything about causality. But I think it was interesting that it associated with both the level of insulin resistance and monocyte metabolism, so that maybe CXCL11 functions as a kind of a bridge between immune metabolism and systemic metabolism.
Interesting.
All right, Lisa, are there any other key points or thoughts that you'd like to leave us with? Or maybe would you like to hint at what's to come?
It's really important that we find out what this metabolic dependency of the immune cells means for their functionality, but also in a broader perspective, what it means for individuals with obesity and how it is involved in insulin resistance. That is one point that is important. And I think with the associations we observed between monocyte metabolism and insulin resistance, it is worthwhile to further investigate if there's any causality between immune metabolism and insulin resistance.
Thank you so much, Lisa. And I am looking forward to seeing you move forward in your career. And this seems like a very important step towards that PhD degree that you are working towards. So we look forward to that.
Thank you.
So thank you for sharing your expertise. And I encourage listeners to read the full article in the July issue of Diabetes. Thank you.
Thank you. Thank you a lot.
Welcome to this edition of Sweet Talk. I'm Kevin Williams.
I'm Darleen Sandoval.
And I'm Kirk Hofegger.
Today, we have the pleasure of speaking with Dr. Rury Holman, this year's recipient of the Banting Medal for Scientific Achievement and previous recipient of the Outstanding Scientific Achievement Award and the Distinguished International Service in the Cause of Diabetes. Dr. Holman is an emeritus professor of diabetic medicine at the University of Oxford and the founder of Oxford's Diabetes Trials Unit. Dr. Holman has had many significant contributions in diabetes research, including the identification of declining beta cell function as a key factor in type 2 diabetes and co-inventing automated diabetes management tools. Dr. Holman also co-led the UK Prospective Diabetes Study, which revealed the benefits of intensive glucose and blood pressure management and highlighted the long-term legacy effects of early glycemic control and metformin therapy. Welcome, Dr. Holman, and thank you for joining us.
Thank you for having me.
We'd like to start these off with a little bit of an icebreaker question. As a leader in diabetes research, I'm curious, if you had to start your career all over again and didn't go into this field, is there any area you think you might have explored? Are there other research topics that might fascinate you?
So I grew up as a teenager in the 1960s. This was the atomic age. And so my dream was to be a nuclear physicist. However, biology was by far my best subject. So I followed the family tradition and studied medicine.
Nice.
You know, Dr. Holman, as an audience member watching the Banting lectures, one of the very fun things is that we get to see the award winner and what they think might be the most significant contribution of their work to the field. I was wondering if maybe you can start by telling us about what you think is your favorite or most impactful contribution.
Oh yeah, I think without doubt it's the results of the 20-year UK Prospective Diabetes Study. This was in 5,102 people with newly diagnosed type 2 diabetes. This study was conceived and run jointly by Robert Turner and me, and we presented it at the 1998 EASD meeting in Barcelona with 5 papers published simultaneously in the Lancet and the BMJ, a record I don't think has been broken. Now, as you alluded before, this showed for the first time that diabetic complications are not inevitable, which many people thought they were. They thought they were genetically determined, but could be prevented by more intensive glycemic control and by tighter blood pressure control. So these landmark findings had a profound impact on the management guidelines for type 2 diabetes worldwide, which were updated to mandate a clear focus on achieving and maintaining good blood glucose control with sulfonylurea or insulin or with metformin. What was truly remarkable was the follow-on 10-year post-trial monitoring study, which surprisingly showed that the within-trial benefits with sulfonylurea insulin or with metformin remain constant. So I call these continuing benefits the glycemic and metformin legacy effects, respectively. And you may have just seen we've published the 24-year post-trial observational data in the Lancet last month. And again, surprisingly, these show that the legacy effects have continued virtually unchanged. So to give you some sense of the magnitude, the relative risk reductions from baseline for all-cause mortality is 11% for sulfonylurea or insulin and 20% for metformin. So these near lifetime benefits are a game changer, showing that maintaining near normal glycemia from day one minimizes the risk of complications and prolongs life.
Such amazing work and hard to top that, but are there any, along the trajectory of your career, what are some other important findings from your colleagues that you think have made an impact on the field?
Oh, I think what has been most impressive was the discovery, testing, and eventual implementation of the GLP-1 receptor agonist and the SGLT2 inhibitor agents. So, as you're aware, these have a major impact on cardiorenal outcomes, some of the more difficult complications of diabetes to offset. They now offer so much hope to people with type 2 diabetes. And then the surprise finding that the impressive weight loss seen, particularly with the GLP-1 receptor agonists in people with and without diabetes, finally gives us a medical intervention for obesity that, with the development of dual and triple agonists that are coming down the line, will likely mirror the weight loss we could only achieve before with bariatric surgery.
Yeah, it's a fun time in this field right now.
Dr. Holman, there are still challenges to address many unmet needs and deficiencies in the treatment of diabetes, some of these being cost and accessibility issues. What do you see as a primary focus for the future to give efficient and accessible diabetes treatment?
Well, I just revert to one thing that you said in the introduction, and that is type 2 diabetes is a disease of relative insulin deficiency. It's driven by declining beta cell function in susceptible individuals, even those of normal weight. And what we need are therapies to preserve or restore beta cell function that would change the pathophysiology and offset the need for other treatments. So let's put that out there as a major focus. My greatest concern, however, in answer to your question, is that despite the proven need to improve the management of diabetes and having the tools in place to do this, good diabetes control remains the exception in many people, especially in underserved communities and in low and middle income countries. We really do need to find ways to make medical advice and therapies more accessible, ideally free at the point of care, as we have with the UK National Health Service.
Excellent points.
Yeah, definitely. Are there any emerging technologies that you think could help with some of this? Or do you think that even on the technical side, we still are going to have access issues for some of these patients?
I think access issues are with us for the foreseeable future, but the thing that's impressed me most is the development of reliable continuous glucose monitoring devices. This is transformative. I've worked on glucose monitoring and all sorts of algorithms for managing diabetes, but finally we have relatively inexpensive and usable glucose monitoring devices, which are so good and so inexpensive compared to glucose sticks that in the UK they're offered free to all insulin-treated patients,
Wow.
type 1 or type 2. And that makes sense because you reduce the burden of the disease for people. They can get on and live a fuller life without having to worry about, pricking their finger frequently and then working out what to do, especially those who have automated insulin pumps that go alongside it. So I think this is a massive development in the field, and I think will be one of the most exciting ways as we go forward, as we learn how to use these to best advantage.
Yeah, wonderful. And you've spoken a little bit about the future and looking forward, but I'm hoping maybe you can touch on what legacy you hope to leave for the field.
Okay, well, I'm not leaving for a while, but
Good, good.
other than my published works, I think, to be honest, my greatest legacy are the many research fellows it's been my privilege to work with and mentor. Most of these have gone on to become full professors, running their own units and designing their own exciting research programs. And some of them still work with me.
Mentoring is a very special thing that we get to do. So
Yeah.
I think that's
Yeah.
that's a wonderful answer to the legacy question.
And building on the mentorship, what advice would you give to young scientists, medical students who are just starting their careers now? Are there any qualities you think that are essential for the success of their career? Any words of wisdom? And then the second part was looking ahead. Do you have any bold predictions for the future of medicine or healthcare, particularly as it relates to diabetes treatment, maybe within the next couple decades?
My sort of take-home message for all young researchers is to be sure to follow your vision. It's all too easy to get sidetracked by day-to-day issues and life events in general. Biomedical research is a vocation. It requires hard work and an eye for detail to spot the unusual and then explore it. The excitement of making new discoveries is what inspires all of us. And to looking ahead, I think the development of AI assistance is going to totally transform the way we work and deliver healthcare. My youngest son is a qualified communication engineer who then trained as a physician, and he now works on AI-driven healthcare platforms that integrate all available data to provide rapid and robust summaries of optimal treatment options to inform more accurate decision-making. And so I've been privileged to see that evolving. And it's quite clear that, with so much information, with proteomics, with genes, with multiple drugs, with rare diseases, it's quite difficult to synthesize that when you're dealing with patients, especially if it's a short period of time. So having these assistants that pull together the relevant information to allow physicians and healthcare providers, to have the option to make the best choice, I think that's really going to change the way we work.
That's interesting, right? Because it's not just that it's the most relevant, but it's the most up-to-date information that an AI could provide, right? Like a summary of the information and
Yeah, I think that's the key. It pulls it together. I don't know that it's ever going to make the decisions itself, as it were.
right.
But what I see it is as a tool. I mean, for years we've always, searched the literature, we've read the journals, but there's just so much information out there. So if you have something that distills it and puts on the page the key points, then the human can come along and make an ethical decision as to how best to move forward. I think it's great.
Yeah.
Dr. Holman, thank you very much for taking the time to speak with us today. For our listeners, I encourage you to take a look at the program for the 84th American Diabetes Association meeting in Orlando. It can be found at professional.diabetes.org/scientific-sessions. The sessions will also be available on demand for a few months after the meeting, so don't miss out. And as always, please follow, like, and subscribe for more Diabetes Bio content.
Thanks to all of you for joining us on Diabetes Bio podcast. We hope that you are enjoying our discussion of the work that the Diabetes Journal is publishing each month. The feature articles we discuss in each episode are freely accessible at diabetesjournals.org/diabetes and are also listed in the episode notes for your reference. As with any podcast, it really helps us if you like, rate, follow, and subscribe to the podcast. And if you have any feedback for us, we'd love to hear that as well. We look forward to presenting to you next month.